Yes,
Yeah,
tell me.
yes, it's very little more. We can't see that difference.
But there is little bit gap, or you can say little bit error of 0.1 centimeter. Correct now?
Yes, yes,
Okay. So three lines when you will draw, the error in each line will be zero point 0.1. So it will make the error of how much?
0.3.
Are you getting my point?
Yes,
So because of this thing, what happened? This circle is not touching all three sides. This circle is not passing from all three vertices.
yes,
So now we cannot remove the error. Okay, remember this thing, we cannot remove an error. So what can we do? We can take precautions, or we can increase our efficiency so that there is minimum
no,
chances of error. Okay,
yes,
right?
yes,
So now how to reduce the error? Let me give you one more example. जैसे आपने suppose first time cycle चलाई है, okay? In that
yes,
situation, आप सोचते होंगे कि मुझे लेफ्ट पैर पहले रखना है पेडल पे या राइट रखना है, ओके? फिर आप जब टर्न
yes,
लेते थे तो टर्न लेते टाइम गिर जाते होंगे कभी, राइट? समटाइम्स इट हैपेंस इनिशियली.
yes, right.
बट अब अगर आप साइकिल चलाते हैं तो यू डू नॉट थिंक अबाउट दैट कि मुझे लेफ्ट पैडल पे रखना है पैर पहले या राइट में रखना है, ओके?
Yes,
Same way, whenever there is turn, automatically you turn your bicycle. So without thinking we are doing. Is it practically possible? Because of maximum practice. Okay, we have done that n number of times. Like in the morning, when you take the toothbrush and the toothpaste, directly you keep it on that without looking at. Sometime if you look also, but when you do the brushing,
yes,
have you ever focused that कि ये मेरे मुंह के अंदर ही ब्रश जाना चाहिए?
no,
No. It means you are now 100% efficient in that case. So that
yes,
efficiency come through practice.
practice.
Okay. Same way, if I want to reduce the error, okay, so I have to take the maximum number of observation. More are the number of observations, probability
Less.
of getting error will be minimum. I hope it is clear to you.
Yes, sir.
Now there are different sources of error. Okay. Now what are these sources of error? The first one, instrumental error. Okay.
Yes,
Suppose a company makes 100 skates, let's say. Okay. And due to change in temperature or any situation, one scale has some error. Okay, it is not perfect one, it has some error. Okay, so that is known as what? Instrumental error. Right, beta?
yes, sir.
And sometimes what happens when it gets older and older, even though suppose 99 are perfect, but as time passes, when we use, their efficiency decreases.
Yes,
Okay, so that is also known as instrumental error. Right, beta?
Yes, sir.
Second one is manufacturer error. Now manufacturer error, what is this? Suppose you are using the scale of Natraj, okay, Natraj company, or
Yes,
Apsara company, or any XYZ company, right? Do you think, or are you 100% assured that whatever scale they have made of 15 centimeter or 10 centimeter, it is the exact 15 centimeter? Can you tell me, or are you 100% assured about that? Can you believe on that? कोई प्रूफ है कि नहीं मैं मानूंगा कि 100% सही है, 15 सेंटीमीटर इतना ही होता है?
no, proof is not there.
हाँ,
Proof is not there, but
Proof is not
We
there.
will.
It means you are using the scientific apparatus devices on the basis of faith only.
Yes.
तो ये तो गलत बात हो गई, right ना?
Yes, sir.
So remember that what is the manufacturer error? The manufacturing company, when it is forming any device, there are chances of being error in that or not also. Okay, both the possibilities are there. There may be defective pieces or there may be some error at the time of manufacturization of all the devices. अब इसमें मान लो इस कंपनी को it makes 100 scales daily. अब 100 scales सर्दी में अगर बनाए और 100 scale winter में अगर बनाते हैं, okay, 100 scales in summer, 100 scale in winter, definitely there will be difference between these two. Why so? In summer temperature is very high.
Yes.
And in the winter temperature is low.
Very low. Yes.
So suppose this is a steel scale. Okay. Now you will take the observation in summer and winter. Will there be the difference between these two?
Yes.
Okay, see? Right?
Yes.
So this is something that causes error. ओके, मैन्युफैक्चराइजेशन एरर जो कंपनी ने बनाया है उसी में एरर हो, राइट? एंड थर्ड वन आई हैव ऑलरेडी एक्सप्लेन्ड यू, दैट इज द एनवायरमेंटल एरर. ओके, whenever there is a change in temperature, pressure, volume, okay, the error occurs, that is known as environmental error. Next one is personal error. अब ये personal error क्या होता है? What is this personal error? See, sometimes in the mathematics when you do the calculation, it is written, suppose कि ऊपर लिखा हुआ है 44 और नीचे आपका लिखा है 21.9. Okay, so for the calculation purpose, what you will do? Yes or no?
Yes.
But exactly, is it equal to 2?
No.
No. So this comes in personal error, right, beta?
Yes, right.
Next one is imperfection in measurement technique. Imperfection in measurement techniques. Okay, like suppose मैं एक experiment करता हूँ Ohm's law. Okay, at the same time in the same lab you perform Ohm's law. Okay, who will get the more precise value of the resistance, you or I? Tell me.
You, sir.
Okay, so that is what, because I am perfect in this experiment and you have done it only once or twice. Yes. Right? Or might be only studied that part. Correct now?
Yes.
So these are the sources of error: instrumental, manufacturization error, environmental error, personal error, and imperfection in measurement techniques. I hope you are clear with this now.
Yes, sir.
Just quickly note down it. See, errors are of different types. Okay, so let me tell you what are the types of the error. See, basically there are two types of the error. Okay.
Yes.
The first one is systematic error. Okay. Now you will be surprised to see the name systematic error. the errors are also systematic, right?
Yes.
And second one is random error. Okay.
Yes.
Now, what do you mean by the systematic error and what do you mean by the random errors? Let me tell you. Okay.
Yes.
Whenever errors tends to occur, okay, tends to occur in any direction. Sorry, in a unique direction, not any, in a unique direction. Now, what is this unique direction?
Only one direction.
Yeah, let me tell you. Like, suppose you want to measure 2.12 centimeter, and when you do the observation, you take the observation, the value is coming like 2.11, 2.10, 2.09, 2 point again 11. So you can see the value is always coming less than the actual value, right?
Yes.
So that error difference is known as systematic. It might happen, suppose another student is doing the same experiment. These are the observation of the first student. The second student is doing the same experiment and getting this result 2.13,
More.
2.14, 2.15. Now here the second student is getting the value more than the actual value, correct?
Yes. Yes.
So either it is completely positive or it is completely negative. So I hope you understood what is the meaning of this unique direction.
Yes, exactly.
Okay. Now suppose a student is performing the same experiment. He want to measure 2.12. Okay. And once he is getting the value 2.09 and second observation is giving 2.14. Again, there might be positive value, there might be negative value.
Negative.
Okay. So this is what random change. So it is known as random error. I hope you are clear with this.
Yes, clear.
We are going to focus only and only on the random error. Okay. What we are going to do? Only random errors. Okay. Now we will see how to measure error and what are the ways to minimize the error. Right?
Yes.
Okay. Note down these two parts, then we will move ahead. Okay. Let's move now to the measurement part of the random error. Right?
Yes.
So let's say we do an experiment, okay, and the observations are A1, A2, A3 dash dash AN. Okay.
Yes.
So first of all we will find the true value or absolute value. Now is it practically possible to calculate true value or absolute value? Can we say that any value which we will measure is true value or the absolute value? No. So what we will do, whatever observation and number of observation we have taken, we will take the average of all these. So it will be A1 plus A2 plus A3 dash 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 AN divided by number of observations. Okay. So mean of all the observation is known as true value or absolute value. First part is clear to you?
Yes.
Now this AM, mean value, there are so many ways to write this. You can write A bar. You can write it in this like bracket. Okay.
Yes.
Right?
Yes.
And you can write this in terms of summation also. Summation AI, the value of I, 1 to N divided by N. Correct?
N. Yes.
Okay. Now absolute error.
Yes.
Okay. Now what is this absolute error? First of all, absolute error is denoted by delta A. Now, absolute error in the measurement of first observation, delta A1, will be A1 minus A mean, or you can say A mean minus A1, both are correct. Okay?
Yes.
Always take the magnitude, right?
Yes, man.
Same way, absolute error in the measurement of second observation will be A2 minus AM modulus. Same way, last one in the observation of nth part, it will be AN minus AM.
Sir, here
Correct,
M is mean only. Here M.
Yes, M means mean, average, this one.
Yes.
Okay.
Yes.
Now, mean absolute error. Remember that mean absolute error. Okay. Now, mean absolute error, how I will write? This will be delta AM. Means whatever absolute errors we have calculated, average of all those. Okay.
Yes.
So it will be what? Delta A1 plus modulus of delta A2 plus then delta AN
N.
divided by N. So it will be mean absolute error. I hope you are clear with this now, beta.
Yes, certainly.
Okay. Now remember that whenever we will take any observation, okay,
Yes.
these observations, let's say is A, it will be always less than and greater than equal to A mean minus delta AM, A mean plus delta AM. So this will be the maximum value and this one will be the minimum value, and this is the observed value. Correct, beta?
Yes. Yes, sir, correct.
Thereafter we will come to the relative error. Now what is relative error? The mean absolute error divided by mean value. Okay, that is what? Relative error. Okay. Then after that there is percentage error. Okay.
Yes.
Now what is percentage error? When the mean absolute error delta AM upon A,
Into 100.
okay, so that becomes percentage error. I hope you are clear with this now.
Yes, clear.
Okay, do it.
Yes.
Okay, now one question we will do related to this so that it will be more clearer to you, right?
Yes.
Shall I clear it now?
Yes, certainly.
Okay. So I am taking one example of NCRT, right?
Yes.
Let's say the 5 observation of the measurement of time that is given to us. Okay.
Yes.
And these values are 2.63, 2.42, 2.71, 2.56, 2.80 seconds respectively. Okay. These are the observations of time period. Correct? Now, what we have to find, first of all, we have to calculate the absolute errors. Okay, absolute errors.
Error.
Then second, we have to calculate mean absolute error. Okay,
Yes.
mean absolute error. Then we have to calculate relative error.
Error.
Okay,
Yes.
and sometimes the examiner is very smart. He will say calculate percentage error only. So irrespective to this, we have to calculate each and everything.
Yes.
Correct now?
Yes.
Okay. So let's do the solution. First of all, the true value we have to calculate. Okay. So 2.63 plus 2.42 plus 2.71 plus 2.56 plus 2.80. Ayush,
Yes.
you might have done the statistics, right?
Yes.
Would you like to learn a new technique?
Yes.
Okay.
Yes.
See,
Sure.
it is known as Ekadikane. What is that method? Ekadikane. Okay. I will share you the link of my YouTube videos for Vedic mathematics. You will learn lot of very interesting techniques there, right?
Yes. Yes.
So see here, what is this Ekadikane meaning? Whenever a dot is kept just above a number, its value is raised by 1. Ekadikane, एक से बढ़ जाना, ठीक है? So if I say 0 dot, it means it is 1. If I say 1 dot, it is 2. If I say 2 dot, it is 3. If I say 3 dot, it is 4. Are you getting my point?
Yeah, I get it.
If I say 4 dot, means it is what?
5.
Okay. Now, Ayush, what happens when we add something now? So we keep the carry, and sometimes we forget the carry. फिर से calculation शुरू, जहाँ भूले थे वहीं से शुरू करना पड़ता है. Am I right?
Yeah. Yes.
Okay. Now here I am telling you the method. First of all, 0 plus 6. 6 आएगा. 6 plus 1, 7. 7 plus 2,
9.
9. 9 plus 3,
12.
12. अब 12 का हमने कैरी दे दिया आगे और 2 लिखा है यहाँ पे. आर यू गेटिंग माई पॉइंट?
Yes. 2.
अब शुरू करते हैं. 8 प्लस 5 कितना होता है बेटा? 13. 13 है. तो हम कैरी फॉरवर्ड आगे कर देंगे. यहाँ कर दिया. सॉरी, जस्ट अ मिनट. यहाँ कर दिया. करेक्ट ना?
Yes.
सॉरी, कहाँ पर आए थे हम लोग? हियर वी वर, राइट? 7 के पास ही थे ना?
हाँ. 8, 5, 13.
जस्ट अ मिनट. 8, 5, 13, राइट? तो 13 का हमने कैरी फॉरवर्ड कर दिया था यहाँ पे.
Yes.
ओके. तो अब कितना बचा हमारे पास? 3. 3 प्लस दिस इज व्हाट?
7, 8.
8. तो 3 प्लस 8,
11.
11 का 1 बचा. क्या आएगा? 1 प्लस 4,
4.
5.
5.
5 प्लस दिस इज व्हाट?
7.
कितना आएगा? 12.
12.
ये 1 कैरी फॉरवर्ड कर दिया और 12 का हमने 2 रखा और 1 कैरी फॉरवर्ड हो गया. नाउ दिस इज 3 प्लस 3, 6 प्लस 3, 9. 9 to 11. 11 प्लस 3,
14.
कुछ मुझे लगता है हमने 2 बार कर दिया है. डॉट कहीं इधर उधर लगा दिया है. ओके, जस्ट अ मिनट. लेट मी स्टार्ट इट विद द बिगिनिंग.
Yes.
Okay, let's start with this. First of all, 0 plus 6 is 6. 6 plus 1, 7. 7 plus 2, 9. 9 plus 3, 12. So 12 का हमने 1 कैरी फॉरवर्ड कर दिया और क्या बचा हमारे पास 2.
2.
Okay. Now this is what 7.
7.
7 plus 4 11.
11.
11 का 1 कैरी फॉरवर्ड कर दिया 1 बचा. 1 plus 7
7.
8. 8 plus 5 13.
13. So
कैरी
1.
फॉरवर्ड कर दिया 3 बचा. 3 plus 8 11.
11. So again
11 1 कैरी फॉरवर्ड कर दिया क्या बचेगा 1.
1.
क्लियर हुआ?
Yes.
अब कितना है ये सबसे पहले 3 plus 3 6.
6.
6 plus 2 8.
8.
8 plus 3
11.
11 plus 2
13.
ठीक है.
Yes.
अब डिवीजन करते हैं नॉर्मल तरीके से तो क्या आएगा 5 2 जा 10 then 5 6 30
6 are 31. 5 2 again.
okay then 5 2 जा 10 and 5 4 जा 20.
20.
यहाँ तक क्लियर है?
Yes.
Now in division we were having a rule. Okay, we will keep the least number of significant figures present in the input. तो input क्या है यहाँ पे 5 is input और this
5.
2.63 और these numbers are input.
The numbers are in.
None. So we will round off it up to 2 decimal points.
Yes.
Correct?
2. Yes.
So if we remove this 4, it is less than 5. So out of after rounding off, we will get what?
2.62.
Are you clear with this mean value?
Yes. Clear.
Now the next thing, what we have to do? Tell me.
Yes. Next now.
Mean absolute error.
Yes.
So delta A1 if I want. Okay. So what I will say, A1 minus AM. So A1 is 2.63 minus 2.62. What I will get? 0.01.
0.01.
Now delta A2. Directly tell me 2.42 minus 2.62 will be
minus 20. 0.20.
minus 0.20. Correct?
Yes.
Delta A3
minus 0.09.
9 or 4? Okay, 9.
No,
9.
yes, plus positive 9.
Next, delta A4
minus 0.707. No, not 7. 6.
0.06. Delta
Yes,
A5.
so it will negative.
Yes, it will be negative.
Negative. 0.18. 0.18.
0.18. Okay. Now mean absolute error we need. It will be always positive. So whatever negative numbers are there, we will make them positive. I hope you are clear with this.
Yes, sir. But that above step we should write in negative, and then next step we should do it absolute one.
So just check it. Have you ever taken the average of negative numbers, beta?
No. Yes.
In the statistics, we have never done this.
No.
Right?
No.
So now if I do this calculation, what I will get, see again 8 plus 6, 14. 1 carry
24.
forward.
It will be 14.
Okay, 14, 1 carry forward. So 4 plus 9,
13.
13. 1 carry forward. 3 plus 0, 3.
3.
Right? Now 1 plus 1, 2
1
plus 1, 3,
5.
4, 5. So 0.53. Yes or no?
Yes.
I think I am missing a number here.
0.01.
Yes. So 0.01 will also come. So plus 0.01. So it will be 0.54, right?
Yeah, 0.5.
Okay. Now after that 0.5 1 ja 5.
Yes.
And 0 5 8 ja
8.
40. Correct?
Yes.
Now again tell me input is what? These digits or
Yes.
this 5?
No, 0.5. 2 decimal.
So now I have to round it off up to 2 digits.
Yes,
After decimal point,
0.11.
0 point. See, Ayush, it is termed as 1 1. After
Yes,
decimal, we
1.
never say 11 12. Okay.
Yes, 1.
So mean absolute error also clear.
Yes.
Now relative error we will calculate delta m by am, and percentage into 100 we will do, right?
Yes.
So I am directly calculating percentage error. So 0.11 divided by mean value is 2.62 into 100. Okay.
And
So when we will do this calculation, tell me what you will get.
to be 11 upon. No, yes. 11 upon 2.6. Yes, sir, something like 4.24 or like that.
4.24.
Yes, approx.
Okay. Now over here, see, if I say the least count, okay. So there
Yes.
is no device which can measure the percentage after the decimal point. Are you getting my point?
Yes. Yes.
So we'll round it off up to 1 digit only, right?
4.
Or else, okay, this is the okay part. Now 2 4 we will remove, so it will be what?
4.
Are you getting my point now?
Yes, sir, here we'll round up to nearest 100.
Yes.
Yeah. Yes, sir. Sir, I should copy this.
Yes, copy it. Only in that case you will be able to do this properly next time.
Now is it?
Okay. So see here, the precision is what? Precise value.
Value.
It tells up to which resolution the value is measured. So here after decimal point, it is measured up to 2 places.
2D.
Okay. Accurate value says how close is the measured value to the true value.
True, yes.
Okay.
Yes.
Accuracy says how close is the measured value towards the true value, while
True value.
precise value says up to which resolution an observation can be taken. Clear?
Yes.
Okay. It means there are more number of more places after the decimal point, that will be precise value, and less number of places after decimal point, it will be accurate value.
Accurate.
I hope now you are clear with this.
Yes, clear.
Okay. Now my one question, is there any way to reduce error? Can we reduce error? Or can I
Yes.
correct an error? Can I correct an
Yes.
error? No. देखो, आपने एक सिंपल सी बात समझिए कि कोई मशीन है, उस मशीन से आप कुछ नया बना रहे हैं, ओके? यू वांट टू मेक एन स्केल. अब स्केल एरर हो गया, स्केल तैयार हो गया. नाउ कैन यू करेक्ट इट?
No, no. Yes.
नहीं कर सकते. Suppose you are doing a mathematics, a sum of mathematics. Suppose you did a mistake in third step, and now you are on the fifth step. So if you will change the third step again, will it affect the fourth and fifth?
Yes.
पूरा इसको भी correct करना पड़ेगा आपको.
Yes.
It means once we have done an error, it is error. It cannot be reduced, or you can say it cannot be removed. So what can we do? We can take the precautions to minimize the error. Are you getting my point, beta?
Yes.
Okay. So today up to this we will study only, right? And
Yes.
I will share the questions related to that. Okay, beta?
Okay, sir.
And one book I am going to share with you. So whatever topics we are studying, some questions MCQs will be there on the basis of that only. Right, beta?
Yes.
Okay, so that's all for today. Thank
Yes.
you.
Sir, add that number in the group which I sent.
Yeah, I will. Okay.
Yeah.
Yeah.